Hi and welcome back to Podcast School. This is another video podcast in the series of Boolean Algebraic Identities. This is part 2. We're studying the SEA syllabus, and that's a Northern Irish syllabus, and of course, as always, this is a technology and design podcast. Okay, so this is just a little bit of revision from the previous podcast. We saw that there were 4 Boolean additive identities. And we saw that A plus 0 equaled A plus 1 equals 1, A plus A, strangely, equals A, and A plus A bar equals 1. Now, I've said plus there that entire time, okay, because of the plus, obviously. But that really reads A or 0 equals A or 1 equals 1, A or A equals A, and A or A bar equals 1. And if that doesn't mean anything to you whatsoever, then the chances are you haven't seen the previous podcast, so you need to go back and review that one. We're going to look at the multiplicative identities today. So we're going to find out what A times 0 is. We're going to find out what A times 1 is, what A times A is, and A times A bar. And just as before, these are AND functions. So that would be A and 0, A and 1, A and A, and A bar. Okay, so this is what we're going to try and find out. All right. Have a look at this circuit. There are 2 switches here that we can see. There's this first one, and there is another one in series, which we've labelled A. Now, the first one is open. In other words, it's a 0. It always is that. And the second one, well, it looks a bit like a capacitor, but don't get confused. It's not a capacitor at all. It's just symbolising that A can be either open or closed. Alright? Now, if A were closed, say, and this first one were to be open, then the output would still be a 0, wouldn't it? Because there's no way that the electricity can flow through this open switch. If A were closed, then the same would also be true. There's no way did I say that the first time? I can't remember. If A is open or closed, alright, it doesn't matter what the switch is. If it's open, then it's just electricity is never going to flow. In other words, it doesn't matter what A is. Have a look at that identity then. That's really what it's saying. If it's saying 0 and A equals 0. In other words, it doesn't matter what that is. I've already said that. If it's open, then there's no way that output can be a 0. And all these multiplicative identities are all represented by the AND gate. If you think about it, that's really what we're saying there. If one input's a 0, it doesn't matter what the other one is. It will never ever be anything other than 0. So you can see that the AND gate represents this quite well. So when you think of multiplicative identities, think of the AND gates. And I've just said there, no matter what the value of A, the output will always be 0 when A is multiplied by 0. In fact, that's no different from regular algebra. Have a look at this one though. This time, the first switch is closed. It's a 1. Now, A, it is dependent on A what the output will be. Okay, so let's just bring in our identity. Look there, 1 and A, notice I said and, 1 and A equals A. Now why is that? Because if A is a 1, then the output will be a 1. In other words, they're both the same. If A is a 0, then obviously the switch is open, so no electricity can flow, so A must be a 0. In other words, the output will always be the same as the value of A. And again, if we bring in the AND gate, you can see that quite plainly. I said there, no matter what the value of A, the output will always be A when A is multiplied by 1. No different from regular algebra. And that's our second multiplicative identity. Next one, have a look. There are 2 again, but both are this weird switch arrangement where either it can be open or closed. So this one is going to be A times A, or A and A. What's it going to equal though? Well, if they're both 0, then the output's 0. If they're both 1, then the output is 1. In other words, A and A will always equal A. Okay, now that's obviously different because you would think in regular algebra that it would be A squared, and that's what I've said there. But obviously we don't have A squared in Boolean algebra, so we just have A. That's quite, if you just think of it in terms of the circuit, this stuff is easy. If you begin to get too bogged down in the identity itself, you can easily become confused. So what I do is I always think of the circuit. And again, you can represent that just with an AND gate with its inputs tied together. And I said there that the product of a Boolean quantity and itself is the original quantity, since 0 and 0 equals 0, and 1 and 1 equals 1. So that's our third algebraic multiplicative algebraic identity. This is the fourth and final identity for today. Have a look at this one. Here we have again two switches. Again we have this funny symbol representing one thing or the other. But the second switch in series is A bar, or the complement of the first. What do you think is going to happen here? Well, if A is 0, then A bar is a 1. Nevertheless, if A is the 0, then if A is 0, then the output will always be 0. But if A is a 1, well then this time A bar is a 0, so again the output is 0. In other words, A and A will always equal 0. Okay? You can see that the circuit, or sorry, the symbols there show that A is at one input and A bar is the other. So A bar will always equal 0. And I've said there that the product of a Boolean quantity and its complement will always be 0, since 0 and 1 is 0, and 1 and 0 is 0. Okay, so that's our fourth and final identity for today. So to recap, we have our additive identities, which we talked about at the beginning, and what was discussed in the last podcast. And now we have four more. A and 0 equals 0. A and 1 equals A. A and A equals A. And A bar equals 0. So this final page that you're now looking at, this really is the truth of the matter and the meat of all our work from now on. You'll see that these are very, very important indeed. Okay, go back if you've missed anything. Remember, check the PDF notes. You can have those, those are in the feed, so if you don't have those, print those out. And indeed, if you've any questions you'd like to ask, you can just email me at info@podcastschool.net. Okay then, until next time, bye bye.